Hello everyone. So this is the second part of the planning process in which I'm illustrating with a given set of examples. And the example I'm using is actually one of the lens experiment which we have done. If you have not seen the other video, can you please go back to the first video and watch first because this is kind of a continuation. The first video which I did focused on analyzing the given equation first, and we try to elicit as much information as we can from the equation. And then in the second part of the video, as is now, we are going to show you how to write out the experimental process. I've already written it down as shown in the video here, but do focus on how I get the information out rather than getting the right answer. So in the first part, again, manipulate the equation until you get y equals mx plus c. Once you get y equals mx plus c, and you have elicited the necessary information from here, you have to describe how you conduct the experiment. Note how I write the step 1, set up the apparatus as shown in figure 2.1. And yes, you can do this step. I'm showing the practical now. This is the practical, and this figure 2.1. Well, you can just tell the examiner you're going to set up the figure as shown here. Right? There's no need to go and draw the whole thing again. And then the next few steps, place the lens so that its center is about 0.200 meters from illuminated object. Measure and record the object distance u. I'll go back. Place the lens so that its center is about 0.2 meters from the illuminated object. Measure and record the object distance u. So this is not a case of I see it, I copy it, okay? No. This step here, 2 and 3. Alright, 2 and 3. You are actually trying to describe how the independent variable is measured and recorded. Okay, step 2 and 3, that's what you're describing, how you use the setup to measure and record your independent variable. And then next, place the screen close to the lens. So you place the screen, you see my cursor, close to the lens, and you see where my cursor is? Close to the lens. And then move it away from the lens, slowly move it away until a focused image of the object is seen on the screen. And then measure and record the image distance v. So for the next two steps, alright, what I have is step 4 and 5, and here they are actually asking to describe how dependent variable is measured and recorded. Now, careful, if you look at the way I write it and the way that you have been given, it sounds slightly different. Read this line. Measure and record the image distance v. Okay, measure and record the image distance v. But if you look at my answer, measure and record the image distance v1. Right, there's a v1 there. Okay, which means to say I'm going to do an additional step. I'm going to collect 2 more sets of v and then calculate the average v. Hence I put v1. Right, so this is what I meant by do not copy blindly. Okay, do not copy blindly. Alright. Measure and record the image distance v1, and then I'm going to repeat step 4 and 5. So I'm going to move the screen close to the lens again. I'm going to move it away until a focused image is seen. And I'm going to do it 2 more times. To collect v2 and v3 and then calculate the average value of v. So this is what I meant initially by saying please do not just take the whole thing and just copy blindly over, right? Modify the steps a little bit to show some understanding. So I'm going to find average values of v, and then step 2 to step 5. Repeat step 2 to step 5. So other than that, I'm going to take these 2 steps, I'm going to mark it out in rectangle, and repeat step 2 to step 5 for increasing values of u to obtain at least 5 sets of u and v. So this is a way to show them you know how to repeat the experiment for varying values of the independent variable. Right, show them how you loop it. Alright, so you can see there are 2 loops here. One is you loop the dependent variable, and the other is you loop the independent variable. Right? There's a loop within a loop. Okay? And then tabulate u, v1, v2, v3, v, 1 over u and 1 over v. Note the sequence. You collected the data u first. This is collected first. Then v1 is collected second. Then v2 is collected third. And v3 is the fourth one. So this you have to tabulate in sequence of collection of data. Right. As of the process data, it doesn't matter the sequence. Okay. It's just that when you do the experiment, you collect u and v. This is a sequence in which you collect the data, and you must tabulate according to the sequence that you collect the data. Right? For v, 1 over u and 1 over v, it doesn't matter. It's just I put it in this way so that easier to plot the graph later. And then the statement of the graph you plot to test the relationship, right? And there's plot the graph of 1 over v against 1 over u. And then they also ask for explanation of how the focal length could be found from the graph. Okay. Now, as of now, when many of you did this worksheet, this is what you all did. You all did this, y-intercept equals 1 over f. Therefore, f equals 1 over y-intercept. Okay. Some students wrote this, c equals 1 over f. Therefore, f equals 1 over c. Well, I teach you, so mathematically I know what you're trying to do. Okay, but they want an explanation. They're not asking for mathematical proof. So I'll suggest you write it in the way I've shown here. Alright. Since y-intercept is equal to reciprocal of the focal length will be equal to reciprocal of the y-intercept. Just write out the whole thing, but I know it's mathematics, but well, let's assume that, well, the marker doesn't know anything. So we write it down and teach them. So that'll be all for the planning stage. I hope that you find this useful.